Now for question number 1, we have aqueous solution of copper salt. Okay, you have this blue colored complex ion. This is similar that with the one that we have studied earlier. Okay, so this one, I think they didn't use the aqueous ammonia. Okay, do remember this reaction is going to be similar if you're using aqueous ammonia drop by drop. Okay, still the same. Okay, but here they said the reaction with aqueous sodium hydroxide. So write down the equation. So the one that is given in your marking key is this one. Okay, copper hydroxide. Okay, but I think we have learned about this as well, which is going to be this, instead of just simply writing it as copper hydroxide, okay, you can write it in this form. Okay, so the one that if you give your answer in this form also is correct. Okay, so the if you are going to give CuOH2 H2O4, okay, and then no charge, okay, plus 2 H2O, this equation is also correct. Okay, because it's still going to give you the precipitation reaction. So this is a precipitation reaction. So it will be the color and the state of the copper containing product. So it's going to be a blue precipitate. Okay, so it's going to be a solid, in solid form. Okay, it's going to be precipitate. So blue precipitate will do, no need to say blue solid. Okay, so here I think don't use this term. Okay, this is, I'm just using PPT over here for your class. Okay, but it's supposed to be blue precipitate, right in full. Okay, so to be exact, okay, in your textbook they mention it's going to be pale blue precipitate. Okay, so you choose which one you want to give. Okay, but it's supposed to be blue precipitate. Okay, it's not solution. Okay, blue precipitate. So next is going to be the reaction with the hydrochloric acid. Very easy also. Okay, you are going to get all the H2O, you remove, you get CuCl4 2 minus. Okay, so write the equation. Okay, this is going to be the equation, and then the type of the reaction is going to be a ligand exchange reaction. Okay, ligand displacement, if you want to use these kind of terms, it's up to you. Okay, and then the color and the state of the copper containing product, this is going to be yellow. This is not precipitation, it's going to be solution. So yellow solution. Okay, yellow solution. Now next is going to be this one, chloride ions can be identified using aqueous silver nitrate. So they have given you some a question where you need to do calculation. So if you read through this question, you say they started with this amount, okay, of this chloride of sulfur, okay, and then all the chlorine atoms present in the chloride of the sulfur are converted into chloride ions. Okay, then the solution is diluted to 100, so it means you have 100 cm cube of this sulfur chloride, and then 25 cm cube is taken. So please take note, you don't take everything. Okay, you took only 25. Okay, 25 is titrated, okay, with 0.5 mole per dm cube silver nitrate. And then they have these results with silver nitrate. So what we can do is, you can find out the number of moles of silver nitrate. So calculate that, okay. So this one times, okay, and then divide by 1000, you get, this is going to be the number of moles. And I know, okay, every 1 mole reacts with 1 mole of this, okay. So therefore, my number of moles, okay, if I can, this is the number of moles of silver ions. So it means I can also find out that it's the same thing, okay. You have the same number of chloride ions, okay. But do take note, this is going to be 25 cm cube. So I need to convert this into 100 cm cube. So I need to times by 5, times by 4, okay. So it's 25, I want 100 cm cube. So times by 4. So I times this by 4. So that I can find out what is going to be the number of moles of Cl ions, okay, in 100 cm cube. Once I do that, I know that, okay, when you have the compound, okay, I just put SXCl(Y). When they dissolve with water, you are going to get ion, S ion, and then chloride ion. I put X and Y over there. Why? Because of this X and Y over here. But okay, I need to find out, okay, related to this. Okay, so how do I find out? If I know the number of moles of Cl minus ion, what else I can find out? You can find out the mass of Cl minus. You can do that. Okay, how? Okay, number of moles equals to mass over mr or ar. Okay, in this case, if I want to find the mass, number of moles times mr. So this is the number of moles. I times with 35.5. I can find out, okay, the mass of chloride ion. Okay, mass of chloride ion. So I have 0.159 gram. So we know that this sample, okay, 0.303 sample, they have sulfur ion and chloride ion. So you found out for chloride ion, so you can find out the sulfur ion, okay, which is going to be just minus. Okay, when you minus, you will get the mass of sulfur ion. So the rest, just put it over here, okay, like table, like what you always do. Okay, 0.144 gram, then 0.159 gram, okay, the one that you calculated, divide with the AR, okay, or in this case, the relative formula mass, okay, and then once you get this, you will get this 4.48, which is the same as this, which is, okay, and then the sulfur, when I do that, okay, 32.1, okay, I get 4.49 times 10 negative 3 also, okay, so I will get the ratio 1 to 1. Okay, what does it mean 1 to 1? The empirical formula is going to be SCL. Okay, so this is to get that 3 marks, okay, you need to go through all this kind of working. Okay, please take note. The important thing, or maybe the confusing part, is this part, the mass of ion. Okay, we normally don't find the mass of ions, okay, normally, okay, but in this case, yes, we need to find. Okay, next. Okay, that's group question number 1, 9 marks. Okay, 9 marks. You see, testing on what? Okay, just on the equation and then calculation. Okay, not bad actually for 9 marks. And then for number 2, okay, this is also theory based. Group 2 nitrates decompose when heated. So when they decompose, they give you metal oxide, nitrogen dioxide, and oxygen. So you need to know about this. If no, you are not going to be able to balance it. Okay, so using that, you just balance, okay, and then you will get these numbers over there. Okay, once you balance, okay, then it's fine. Okay, you will get that 1 mark. B, describe and explain how thermal stability of nitrates changes with increasing atomic number. I think why they use increasing atomic number rather than using why going down the group. I think when we say going down the group, students will tend to use the increase in shell. Students may tend to use shielding effect. Okay, so to prevent that, I think they are using this increasing atomic number. Okay, but you need to know which one you need to focus, okay, to give the answer. Okay, so in this case, we know the thermal stability of group 2 nitrates. The stability is going to increase. Okay, stability is going to be increasing. Okay, let me check whether you guys can. Okay, I'll share the screen again here. Okay, let's continue. So here, okay, the thermal stability, okay, is going to increase, okay, and then why? Because as you go down the group, okay, when you go down the group, cationic radius, okay, the cationic radius, it means we're talking about group 2, the cation, the radius is going to increase. When the radius is increasing, okay, you are going to get less polarization, okay, or less polarizing ability towards the nitrate. Okay, so less polarizing ability, or you can say the electron clouds are going to be less distorted. Okay, so because of that, okay, because of that, the thermal stability will increase. It's going to be more stable. Okay, so it means it's difficult to break the bonds between the nitrates. Okay, so please utilize, okay, everything over here. I think the same thing that we always use here is the cationic radius. Okay, cationic radius. Now, C. The variation in the thermal stability of group 2 amides are the same as the group 2 nitrates. This is important because they are testing something that is not in the syllabus. Okay, because we don't actually look into the thermal stability of amides. Okay, but they already say it's going to be similar, so we just need to evaluate only. Okay, so we learn about carbonates. Okay, we learn about nitrates. Okay, so now they are extending it to amides, but they are telling it's similar. So the moment they say it's going to be similar, okay, that is going to they're telling use the same knowledge, okay, that you have, okay, and then relate them to this, okay. So suggest, okay, whether calcium amide, okay, will decompose more or less readily than barium amide. So I want to suggest, okay, I know the barium is lower, calcium is at the top, okay. When calcium is at the top, it's smaller, okay. The cationic radius is going to be smaller, and then because of the smaller ionic radius, okay, calcium, and then greater charge density because of that, okay. So because of these two, okay, greater charge density and smaller ionic radius, this is going to make, okay, the polarizing power to be greater, okay, for calcium. So it is going to be more readily, okay, the calcium amide will be more readily decomposed, okay, because of the small ionic radius or greater charge density. Okay, you just explain. And then this compound decomposes when heated to form, okay, these two. So you need to write the equation. So just simply write the equation and try to balance. Okay, I'm not going to teach you how to balance. You need to do it yourself. Okay, learn. Now, the next question is, you have this ion, okay, NH2 minus ion. Do remember nitrogen has 5 valence electron, okay, but since there's going to be another one more electron over here because it's ion, okay, so therefore you are going to have different combinations of the lone pair and bonding pair. Okay, so if you look at when we say predict the bond angle of NH2, okay, if we predict the bond angle of NH2, okay, explain the answer using this. So when we have nitrogen, okay, just nitrogen alone, so one of the electron is used here, another electron is used here. So you might have 3 more electrons because nitrogen have 5 valence electrons. So because of the NH2 minus, therefore there's another one more electrons over there. So because of this, you are going to get 2 lone pair of electron and 2 bonding pair. Okay, because of this, we are going to have, okay, the bond angle which is similar to water. Okay, so therefore, okay, the bond angle is going to be 104.5 degrees. Okay, that's going to be the bond angle. So explanation will be, you need to mention about, okay, the 2 bonding pair and 2 lone pair. You need to mention about that. And you need to also mention that the repulsion, okay, between the lone pair and lone pair is greater. Okay, and that will make the bond that we measure over here. Okay, the repulsion over here is going to be greater. So this bond is going to be, the bond angle will become smaller, okay, than expected. Okay, so please remember that. Okay, answer key, they do accept, okay, 104 to 105 degrees. Okay, so that is the